Welcome back, Stella. Hope you are doing well. So today we're going to start with this exercise of part two. They said express this 1 all over 3t plus 1 into t plus 3 in partial fractions. So that's the first part of the question. Use an appropriate substitution to show that the integral from 0 to pi on 4 of 1 all over 3 plus 5 sine 2x dx equals to the integral from 0 to 1 of 1 all over 3t plus 1 into t plus 3. You understand? Hence, show that the integral from 0 to pi on 4 of 1 all over 3 plus 5 sine 2x dx equals to 1 on 8 din of 3. That's a very simple question. You understand? That's a very simple question. So we start with the first part. The first part which states that express this in partial fraction. That's very simple. Let me go to the solution. A minute. Let me go to the solution. So correction of type 4 part 2. We are expressing this in partial fraction. These are linear expressions. So this impartial fraction will be a all over 3t plus 1 plus b all over t plus 3. From there, you write back this. The LCM here will be exactly what is here. So we have this as LCM. This divided by this, we have a into t plus 3 plus b. This divided by this will give b into 3t plus 1. Is that okay? Now, okay. Now, since this numerator is the same as this new numerator, naturally this one will be identical to the top. So 1 is identical to a into t plus 3 plus b into 3t plus 1. When t equals to minus 3, I hope you know where this minus 3 comes from. You find the zeros of this and this. When t equals to minus 3, when I substitute minus 3 here, this becomes 0, and I'll have here 1 being equals to b into 3 times minus 3 plus 1. That will give 1 being equals to minus 8b, and b will be minus 1 on 8. Is that okay? Now, let me go to the next. For this one, when t equals to minus 1 on 3, we'll have 1. This other side, when t equals to minus 1 on 3, this will become 0. We'll be left with 1 being equals to a into minus 1 on 3 plus 3. Is that okay? So let me go down. So I'll be left with 1 being equals to 8a all over 3, and a will be 3 on 8. This implies this will be identical to 3 on 8 all over this plus minus 1 on 8 all over this. And finally, our partial fraction, this impartial fraction will be equals to this. That was the first question. The next question we're asked to do was use an appropriate substitution to show that the integral from 0 to pi on 4 of this is equals to the integral from 0 to 1 of this expression. So let me go back to it. So they are asking us, we have to proving that the integral from 0 to pi on 4 of 1 all over 3t plus 5 sine 2x dx is equals to the integral from 0 to 1 of 1 all over 3t plus 1 plus t plus 3 dt. Is that okay? Okay, it's very simple. We know that to integrate this, our substitution must be what? We are supposed to let t to be equals to what? Tan 2x divided by 2. Is that okay? So our substitution is t equals to what? Tan x. Is that okay? Now, since we did look at something, the boundaries here were what? 0 and pi on 4. If we are doing, this is a change of variable, we are changing from t, we are leaving from x to t. We are transforming everything in terms of t. That means we have to do a change of boundary. So I will draw a table. On my table, I will have on the top x and below t, because I'm leaving from what? X to t. What are the boundaries of x? X takes as lower bound 0 and its upper bound is what? Pi on 4. Is that okay? Now, I'll need to find t when x is equals to 0 and when x is equals to pi on 4. This is the expression that will help me to find that. When x is equals to 0, I come and substitute 0 here. I'll have t being equals to what? Tan 0. Tan 0 is what? 0. That's already the lower bound, the corresponding lower bound for t. Now, when x equals to pi on 4, I substitute here. T will be equals to tan pi on 4. Tan pi on 4 is equals to what? Is equals to 1. So we have already, when we will do the change of variable, we have already what will be the lower bound and what will be the upper bound. Is that okay? Now, let's proceed on this side. We had our substitution t, which was equals to tan x. This implies dt will be equals to what? D of tan x. And dt will be equals to 1 plus tan square x dx. Then we make dx the subject. Our dx will be dt on 1 plus tan square x. But remember, t was equals to tan x. This implies dx is equals to dt on 1 plus t squared. Is that okay? Okay, that's perfect. Let's continue. Now, in our integral, we have to find sine 2x in terms of t. Is that okay? So let me move up. So that's why I said, let's now draw our right angle triangle in order to find sine 2x in terms of t. We know that our substitution was t being equals to tan x, and this t is the same as t on 1. This is the opposite and this is the adjacent. So I draw my right angle triangle. The angle is what? X. I put my x here. What's the side opposite to x? It is this side. So the t is supposed to be here. And the side opposite to x, this angle, the side adjacent to this x is this side. So 1 is supposed to be here. And naturally, the hypotenuse will be, according to Pythagoras, the square root of 1 square plus t square, which is this. Now, we need to find our sine 2x. Is that okay? What is the question that I asked? Sine 2x equals to what? We recall first of all that the thing is that we cannot find directly sine 2x from the triangle because the angle here is instead sine x. So I recall that sine nx is equals to what? 2 sine nx divided by 2 cos nx divided by 2. This implies our what is supposed to be 2 for it to be sine 2x? What is supposed to be n for us to have sine 2x? We're supposed to replace where we see n by what? 2. So sine 2x will be equals to what? 2 sine 2, we replace 2 here. We replace 2 here. That will give sine 2x on 2 cos 2x on 2. So this implies sine 2x equals to 2 sine x cos x. Now, this sine x and cos x, we can find it from the triangle because the angle there is x. Is that okay? So we shall proceed in calculating that. Now, from the triangle, you see that sine x will be equals to what? Sine x is opposite of our hypotenuse. So we're going to have t on root 1 plus t squared. Cos x will be what? Adjacent all over hypotenuse, which will give 1 all over the square root of 1 plus t squared. Is that okay? Now, this implies we substitute this sine x and cos x in this expression, So we're going to have sine 2x being equals to what? 2 times t all over root 1 plus t squared times 1 all over root 1 plus t squared. From there, we have sine 2x being equals to 2t all over 1 plus t squared. Is that okay? Now, we need to find this expression. 3 plus sine 2x will be 3 plus 5 into what we just found, sine 2x. So let me go on the next page. So this implies 3 plus 5 sine 2x will be equals to this. I will rearrange things. This will multiply this. We are going to have 3 into 1 plus t squared plus 5 times this. We have 10t all over this 1 plus t squared. So this is our 3. Our 3 plus 5 sine 2x is equals to this. We then substitute things in our integral. we're going to have the integral from 0 to pi of this will be equals to, when we did the change of variable, what was the lower bound, the corresponding lower bound of when we were working t? The lower bound was 0. And what was the corresponding upper bound? The corresponding upper bound was 1. So that's why we are integrating from 0 to 1. Is that okay? Our dx was dt on 1 plus t squared. Is that okay? All over this, which the expression is this, we substitute it from there. Wait a minute. So from there we rearrange things. This would cancel with this, and I will be left with the integral of 0 from 0 to pi on 4 of this will be equals to this. Now we have to check if this is factorizable and factorize it. So let's see if this, so let's see if this is factorizable. I calculate delta, which is b square minus 4ac. That will give 10 square minus 4 into 3 times 3. So that will give delta b equals to 64, which is greater than 0, implying this is factorizable. This implies, so that implies, let me go down. That implies our t will be equals to, this is the quadratic formula. Our t will be equals to minus b plus or minus the square root of delta over 2a. So our t will be equals to minus 10. I first take the minus root. Our delta is 64, root 64 all over 2 into 3, because our a is 3. Or t will be equals to minus 10. I take now the plus root 64 all over 2 into 3. This implies our t will be this. Let me go up. So this implies our t equals to minus 3 or t equals to 1 on the minus 1 on 3. Is that okay? From here, there's something I taught you. From here, you deduce that what t plus 3 will be equals to 0. This implies from here, t plus 3 equals to 0. That is, t plus 3 is a factor. Now, how do you get this 3t plus 1? It's very simple. You have t being equals to minus 1 on 3. When you cross multiply, because this t is the same as t on 1, when you cross multiply, you have 3t being equals to what? Minus 1. From there, you have 3t minus 1 being equals to what? 0. So 3t plus 1 is not minus. So from there, you get this. Is that okay? So that's how I did. So that's how I left from here to here. You understand? Okay. So we basically now have that this is equals to what? Is equals to this times this. Is that okay? Now, so we can conclude that the integral from 0 to pi on 4 of dx all over 3 plus 5 sine 2x is equals to what? The integral from 0 to 1 dt all over what? 3t plus 1 into t plus 3. So we have already proven it. This is the question that was asked to us. We're supposed to prove this. So we have already proven it. Now, they are asking us to show that the integral of this is equals to 1 on 8 ln 3. Let me go back. So the last question, we are to show that this integral is equals to this. Recall that we previously showed that what? We previously showed that this integral was equals to what? This integral. So this integral, we previously showed that this was equals to this. Is that okay? And recall also that we had already expressed this in partial fraction. In partial fraction, this was equals to this. So this simply means this integral, which is equals to this, will be equals to what? So the integral from 0 up to dt of this will be equals to what? I'll just bring this integral inside. Is that okay? So I'll have 3 on 8 integral from 0 to 1 of dt all over 3t plus 1 minus 1 on 8 integral from 0 to 1 of dt or all over t plus 3. Is that okay? Okay, let's proceed. Let me drop this down. Okay, now from here, when you look at this, I have 1 on 8 which is common here. I'll factorize 1 on 8. This will be equals to the integral. I'll bring inside this 3 dt into 3t plus 1, integral from 0 to 1 minus integral from 0 to 1 of dt all over this. Is that okay? Okay, perfect. Let me go down. Now let's first find this integral. So I called this equation 1, this whole thing. Let's find this integral and this integral. From there we shall come and substitute the answer here and calculate. Is that okay? Let's finding integral of 3 dt all over 3t plus 1. We know that this integral will be equals to what? This is a how do we call this since this integral has boundaries, it is called what? A definite integral. And we know that the integral of this will be equals to what? Capital F of 1 minus capital F. We assume, yes, minus capital F of 0, where our capital F of t will be what? The primitive of this. Will be the primitive of this. Is that okay? So I hope you understand what I did. So I'll first find this primitive. I know that, but this primitive of 3 dt all over 3t plus 1 is equals to 3. I put the 3 outside. 3 integral of dt all over 3t plus 1. We integrate this how? This is the same as integrating 1 all over ax plus b, which will be equals to, don't forget there is this 3 outside. So I'll first have 3 times, then the integral of this 1 all over 3t plus 1 prime ln of the absolute value of 3t plus 1 plus our constant k. Don't forget the constant. Now, when you differentiate this, you are going to have 3. This 3 will go with this 3, and from there we'll be left with the integral with, there's a 3 here because there was 3 here. So this implies the integral of 3 dt all over 3t plus 1 will be equals to what? Ln of the absolute value of 3t plus 1 plus the constant k. Is that okay? Now, our f1 will be what? I'll replace this, I will replace 1 here. I will have 3 plus 1, which is 4. Absolute value of 4 is 4. So f of 1 is ln of 4. F of 0 is what? F of 0, when I replace 0 here, I will be left with ln of the absolute value of 1. Absolute value of 1 is 1, and ln of 1 is 0. So we are going to replace this f of 1 and this f of 0 where? Inside here. So let me go on the next page. So from there, we are going to have f of 1 minus f of 0, which will be ln of 4 minus ln of 0, which is ln of 4. So the integral from 0 to 1 of, this is 3 dt, of 3 dt, 3t plus all over 3t plus 1 is ln of 4. Is that okay? Now let's find the other one, integral from 0 to 1 of dt all over t plus 3. Is that okay? We know that this is a definite integral because it has boundaries. So this integral is equals to what? Capital G of 1, the upper bound, minus capital G of 0, where our capital G of t will be what? The primitive of this of dt all over t plus 3. Is that okay? Now, but we know that this primitive dt all over t plus 3 is equals to what? This is the same as integrating a linear function 1 all over ax plus b, which will be 1 all over t plus 3 prime ln of the absolute value of t plus 3 plus the constant k2, where k2 belongs to r. Is that okay? Now, this implies the derivative of this is simply 1. So the integral of this will be equals to this. So we can already find g of 1 and g of 0. Our g of 1, when I replace 1 here, I'll have ln of absolute value of 4. Absolute value of 4 is 4, and so g of 1 will be equals to ln of 4. When I replace 0, we are calculating g of 0. When I replace 0 here, I'll have ln of the absolute value of 3. Absolute value of 3 is 3, so we're going to have g of 0, which is equals to ln 3. G of 1 minus g of 0 is equals to what? Ln of 4 minus ln of 3. Is that okay? Is equals to ln of 4 minus ln of 3. So we can conclude that the integral from 0 to 1 of dt over t plus 3 is equals to this. Now, we are going to go back to this equation. Remember this equation. We have already calculated this. We have calculated this. We have to come and substitute them. So this is where we are. So this integral that we'll be finding was equals to this. We have to substitute this and this. We know that this gave what? Ln of 4. And this gave what? There's a minus here. Minus, we open the brackets. This gave ln of 4 minus ln of 3. So this ln of 4 will go with this. And we'll be left finally with what? This minus will make this plus. We'll be left with 1 on 8 ln 3. So we can then conclude that the integral from 0 to pi on 4 of dx all over 3 plus 5 sine 2x, which was equals to integral from 0 to 1 of 1 all over 3t plus 1 into t plus 3 is equals to 1 on 8 ln 3. Very simple. Is that okay? So I hope you understood the whole procedure. The whole procedure, how we integrated everything. I'm sure you were maybe confused on how this 0 and 1 were supposed to come out. So this how they come out. When you are doing your change of variable t here, you also do a change in boundaries. You understand? So that's the thing. So if you notice, when we were doing previous integrals, we were not usually doing this change of boundaries because we did everything possible to leave our answer in terms of what? The starting variable. So there was no need of doing the change in boundaries. But here, they wanted us to also do the change in boundary. Is that okay? So that's how you did things. So we're going to move to the next question. Let me see. So this is the next. Let me go on the exercises. So our next question is this. Yes, this star. The part 2 question 2 part 2 question 2d. So we are to prove that the integral of 1 all over sine x cos x dx equals to 1 all over root 2 ln of the absolute value of sec x minus pi on 4 plus tan x minus pi on 4 plus the constant k. Okay, this is a very important question. Take note of this question because there are a lot of things I'm going to teach you in this question. There are a lot of things I'm going to teach you in this question. It is a very tactical question. So take note of this question. Take note of it. So in the next video, because I don't want the video to last long, in the next video, I'm going to explain how I went about to prove this. So see you in the next video.